I get a separation of the files, okay? First of all, one communication. Monday, there is the survey of your opinion, and you know that you have to be here. I already explained to you how we use the results from the survey, correct? Sorry, I have to go since I don't remember if I already explained to you. Because you know that there is a question in the survey of your opinion. Did the teacher explain in detail what is the purpose of getting your opinion? And therefore, I take care every year of explaining to the student what is the purpose, because also I think it helps me to convince the students to attend the day when the survey is taken. Did I already tell you? No? Okay, so let me take 5 minutes for this. And first, it's on Monday morning, and I really would appreciate very much if you are attending. First, there is a very quantitative reason. If there are less than 10 students, the survey is not considered by the university. And therefore, it's a problem. It's a problem because, you know, it's a lack of information. And I have communicated the results anyway, but the results are not used by the university to compute statistics. And therefore, it's a loss of information. So my target is on Monday, I need at least 10 students attending. So today you are 9, so I think there is a good chance of getting 10 students. And your attendance was at most during my lectures of 14. So please tell your colleagues, I will send an email through the list to invite you to attend. I'm very keen, I really would like that everybody is there. And so what is the purpose of getting your opinion? Of course, the purpose is getting a feedback from you. And this feedback is extremely important for several reasons. The first reason is a feedback for the teacher, and this is my main reason. I really would like to get your feedback. Of course, I always ask for your feedback, but this opportunity is particularly important because you are anonymous, and therefore you may feel more free of expressing your opinion. So first reason, I really would like to get your feedback. Second reason is that also the university would like to get your feedback. And this feedback is used by the university to distribute resources to the department and to get an evaluation of the teaching capability of professors. And what happens is that these statistics, provided that at least 10 students attended the survey, these statistics are used by the uni in several algorithms for the distribution of resources to the department. Like, for instance, for the distribution of the resources related to personnel, like positions of researcher, professor. They use this parameter, quality of the teaching in the department as a whole, as a criteria. And also in the distribution of the number of PhD scholarships. You know what is PhD, I guess. It's the third level of education after the university. The first level is the bachelor, the second level is the master, and the third level is the PhD, which is a course that is lasting for about, it depends on the country, but 3, 4 years, 5 years in some countries, where the student is paid with a stipend that is, not really much, but still it's a salary. And the student is expected to learn and to make research. So, in order to pay the students, the department needs scholarships, and again, the opinion of students is used as a criteria to distribute these scholarships. Also, it is used as a criteria to distribute resources to the department for organizing services to students, and at the end of the story, it's used as a criteria for individual teaching. And the way it affects the professor is through some constraints on the increase of salary. The salary is periodically increased to any public worker in Italy, basing on the, we say on the age, but it's length of the service. So every 3 years the salary is updated because it is taken into account the fact that with a longer experience, the employee needs to be more paid. And this advance of the salary is constrained for professors on getting a minimum score in the survey of the students. This is a first example. A second example is that they compute statistics at the university level. The best 30 professors are recognized by the rector, like the rector sends a letter, which is not a public letter, it's an individual letter sent to the professor and says, look, you were pretty good, you are in the best 1% of our teachers, and therefore I'm very grateful to you. And the lowest 1% is called by the rector to provide a justification, and the university suggests a solution to the problem, because if you are in the lowest 1%, of course, it means that there is a problem if a professor is in the lowest 1%. And these statistics are computed in this way. In the survey, there is, in the past I used to say there is a front and a back, because it was a sheet with a front sheet and the back side. And now it's in electronic form, so it's split into parts. In the first part, you have to give scores in a scale from 1 to 4, 2 specific questions. In the second part, you're allowed to put comments on questions that are specific but quite general indeed, not really. Are more general with respect to the questions of the first part, like a general question, but you compiled this survey before. A general question is what are the topics that you understood better, or what are the topics that you understood where the teacher was not so clear. And so 2 parts. The first part, where you are required to answer with a score from 1 to 4, is used to compute statistics. The second part is only used by the professor as a more detailed feedback. Okay, so keep in mind the distinction between the 2 parts. This is extremely important for you to know. First part, it's computer statistics. Second part is a feedback that is read by just the professor if he wants to read it, because maybe that some professors are not interested. So the second part is just a communication. It's a textual part communication. The first part is used for statistics. And the way statistics are computed is these scores from 1 to 4 are split in two parts. Score 1, 2 and score 3, 4. Actually, it's not, they are not numbered. The scores are stated in this way. Score 1 is definitely no. Like, are you happy of Montanari? Definitely no. The score 2 is yes, no and yes. Score 3 is yes and no. And score 4 is definitely yes. So keep in mind that they are split in 2 parts. So the first 2 scores are grouped together, and they count just together. And so there is no difference between definitely no and no yes. And in the same way, there is no difference between yes and no and definitely yes, at least for computing statistics. Then, when the rector selects the best 1%, he also looks at the number of definitely yes. But for computing statistics, it's just split into 2 parts. So keep in mind that the effect of the survey doesn't make any difference if you say definitely yes or yes and no. So score 3, score 4 for computing statistics, and for the main scope of the survey, there is no difference. There is a difference if you want to explicitly allocate the professor in the best 1% or the lowest 1%. I hope I was clear. So if the moral of the story is, if you are in doubt between definitely yes or yes, no, score 3 or 4, just consider that your doubt doesn't have any effect on the statistics of the university. It may have an effect on the recognition or the recognition of the rector. So this, I think, it may help you to decide if you want to give definitely yes. It means, okay, I was very happy with this teacher. I really would like to push him in the best 1% or 2%. Or I definitely disliked him, and I want to give a clear signal, to put this teacher really in the lowest, but again, from the point of view of global statistics, it doesn't make any difference. A second thing is beware of the difference of the meanings between the first and the second part. So, if you want to affect the professor, you have to concentrate on the first part. If you want to deliver a message to the professor, but don't want to affect him, her, negatively or positively, then the message is to be given in the second part. So, what may happen is that sometimes students, in the first part they give good scores, and then in the second part they are critical. It's not a contradiction, it's not something that is inconsistent. They want, from a numerical point of view, they don't want to be critical with the professor because they were happy. But at the same time, they take the opportunity of the second part to give some criticism, which didn't affect their positive opinion, but still these are suggestions to improve. And I think this is fully consistent. Like you may say, I was very happy with Montanari, but still I think he can improve here and there. And therefore you may have a high score, and in the second part you just say what you think I need to improve. It's not inconsistent. The opposite may be true. You may say, you may think, Montanari doesn't have any meaning, he doesn't understand what I say, so I don't leave any message, and in the first part I say I give a negative score, because I want to give a clear signal, and I think it is useless that I write down a motivation. This is something that sometimes happens. So sometimes it happens that professors get very negative scores and no motivation. Or whatever you want to, you think it's appropriate. But keep in mind the difference. So in the first part you are in a way affecting the teacher also from a quantitative point of view. In the second part, not. Okay, and one other thing I wanted to tell you, and I really would like to get your feedback in the second part. So, in both cases, whether you are happy with me or not, in any case, if you are happy in the second part, please, any suggestion that you may have, it's good. Also, I would like to get your opinion about these activities that I started this year for the first time. I realize that if I directly ask you, it's difficult for you to say, I was not really happy with this. It's a waste of time. If you think that it was not useful, then please write it down. You may decide maybe not to affect my scores if you think that, I was in a good faith, but at the same time, if you are not happy, just write it down. And in the same thing for good things. If you think that there are good things in my teaching, please write it down. It's in the second part. Nobody reads it, but I read it. I mean, nobody other than me reads it, but I read it. And I really would like to know what was wrong and what was instead for you good. There is no need to say that I am a very good teacher, and there is the need to explain why. So if you think I was very good, please explain why. If you think I can improve, please explain why. There is no need to say he's fantastic or he's bad. And it is the reason, the motivation that is interesting to me. Okay. That's it. Do you have any question on the form, on the questionnaire? There is one thing that I wanted to tell you. I think this is an extremely important step of your student career. So, to have the opportunity to express your opinion, and you are sure that the university, and maybe the teacher, in this case you are sure because I'm telling you that I'm reading it, take into account your opinion, I think it is an extremely important step. And also for this reason I would like you to be attending. It's a way of expressing opinion in a democratic system. So you shouldn't miss it. And keep in mind that this right that you have is efficiently used if it is objective. So you should avoid bias, both in the positive and negative side. Also because in computing these statistics, the tails are sometimes discarded. Like if a professor gets 100 forms, it may be that the upper 5% and the lower 5% are discarded in computing some statistics. This is a usual statistical technique. If you want to increase the robustness of a statistic, you discard the tails. And this should be considered by you. So if your opinion is objective, is credible, it is powerful, effective and efficient. If for some reason you are biased, and in both ways, positive and negative, it's not efficiently used. This is my advice for you. So try to be objective. And I insist on both sides. So there is no need to exaggerate, either positively or negatively. Okay, questions? No questions. Okay, and on Monday, please. And if you can spread the voice, I will appreciate it. I'm not expecting more than 14 students, because it was the max attendance that I had. I hope to be above 10. Okay. Today's lecture, I have a couple of things to say. It seems to me that there is something wrong here, so let me see. Just 1 second. No, I think it is just, the problem is just here. Okay, now it's fine. Just a brief reminder on where we are. So we are getting close to concluding the lectures. Oh, sorry, this is wrong. And we are close to concluding, and we started by talking assessment of water resources availability, and then we studied the river barrages, and then we talked about assessment of human impact. Assessment of human impact is directly related to the assessment of water resources availability. So on the one hand, we studied methods for estimating the availability of water resources, and then we followed up with correcting our estimate, refining our estimate by assessing the human impact. And this was the subject of the last lecture. Now we are moving to the final part of the course, and the final part wants to concentrate on sustainability of water resources with some more details. And today we are talking about sustainability of groundwater resources, and she anticipated my lecture with a presentation that was very appropriate. And then I'm planning, I think we have time, to speak on Monday on sustainability of surface water resources, and therefore I would like to speak about water quality, surface water quality. I'm not sure we will have time to do that, but today let me focus on sustainability of groundwater resources, and then sustainability is the closing part of our subject. Before moving to sustainability of groundwater resources, I would like to say a few words about a topic that I'm not teaching this year, which is extreme river flow estimation. When we discussed the river barrages, we understood the importance of checking the functioning, the effect, the impact of any infrastructure that interfere with rivers on the impact on flood flows, and in particular flood levels. This is a topical issue. Every time that you interfere with a river, and one possibility is the fact that you build a barrage to to withdraw water from the river. Anytime that you interfere with a river, there is an authority requiring that you check the impact on the flood levels. And depending on the importance of the river, you have to refer to different authorities, but this is a requirement that is almost always present. Sometimes you can skip it if it's very clear that your infrastructure doesn't interfere with flood levels. But like if you build a bridge and you don't have any abutment or pier into the river, because the bridge is suspended, modern bridges try not to put any pier, any pillar, to be better understood, and any abutment is the part of the river that is on the sides. Modern bridges try not to interfere with any structure with the flow. In this case, if they don't interfere at all with the flow, it's clear that there is no impact, and therefore the authority may skip the requirement. But any time that you interfere with the flow of the river, and the river has some importance, you are required to check the impact on flood flows, and flood levels are more important, because of course you don't have to increase the hydraulic risk upstream and downstream. In order to make this check, you need to study, to estimate the peak river flow. It's a completely different topic with respect to estimating surface water availability. We deal with river flow data in both cases, but estimating the peak flow is completely different with respect to estimating the whole regime of the river in order to assess water resources availability. And you have to use different techniques. Estimation of the peak flow is not a central topic in our subject, in our classes, because we are interested in estimating water resources availability. But still, it has an implication. So you may require to estimate the peak. I assume that in other courses you focused on peak flow estimation, and therefore I decided this year to skip this topic. Still, I do agree here. This doesn't mean that I'm asking anything at the exam. I'm not asking anything at the exam about this. I wanted to put it here for your information. So if you need a reference, I think this page is unconventional. I think it is useful. Of course, I am biased, so you don't have to trust me, but I thought better if I put the link there for your future use, for your information. As I said, if you deal with infrastructures, dealing with rivers, it is a useful information, but we skip it. Last year I did it. This year I'm skipping it because I want to concentrate on sustainability of water uses, and in particular groundwater, and in particular saltwater intrusion. She mentioned it very briefly. And so I'm not talking about sustainability of groundwater resources in terms of quantity. It's a different topic with respect to assessing groundwater resources availability, which we already dealt with, not in the details, but we talked about the physics. This is a topic related to groundwater pollution. Saltwater intrusion, of course, it's important where? In coastal areas. But still, coastal areas are a very important part of our planet from a societal point of view. If you look at the population that lives in coastal area, I don't remember the number, but it's a significant part of the global population. I may give you the number later because it's in another page. Like 20%. I may be wrong, but not too wrong. So coastal areas are extremely important. And if there is a lot of population there, it's clear that there is a significant water demand. And for this reason, I decided to concentrate on saltwater intrusion, because this is extremely relevant in terms of sustainability of groundwater resources. Sometimes we are concerned by many issues related to sustainability of groundwater resources. There is the issue of contamination from above, like infiltration of contaminated water. There is the issue of overexploitation, which reduces groundwater availability. There is the issue of saltwater intrusion. I am convinced that this is, if I had to give priorities, of course it depends on the location, but I am convinced that at the global level, saltwater intrusion has the priority with respect to other forms of groundwater pollution and with respect to overexploitation. Of course, as I said, it depends on the area. If you are far from the coast, it's not a priority. But keep in mind that saltwater intrusion may affect even areas that are very far from the coast. We will see why. Okay, so let's talk about saltwater intrusion. So what is saltwater intrusion? I have a PowerPoint presentation which should be linked here, yeah, and I prefer to use it. As usual, it's a summary of the content of the lecture. It's better if I need to open the zip file, just 1 second. Here it is. So what is saltwater intrusion? It's the flow of seawater into freshwater bodies, like rivers or aquifers. So we talk about saltwater intrusion also when dealing with rivers. How can saltwater intrusion happen in rivers? It's very simple. Usually the river, by definition, delivers fresh water to the sea. In fact, when the river flow is significant, in the proximity of the river mouth, you have a content of salt in the sea that is lower with respect to the average in the whole sea, because there is a flow of fresh water from the river, from the land to the sea. But if you start pumping water from the river, and if you dam the river, so if in some way you reduce the flow of the river, then at the river mouth the flow can revert. You have a flow of salt water getting into the river because you are pumping from the river. So it's clear that if you pump from the river and you over pump from it, and your pumping brings the water level into the river at a lower elevation with respect to the sea level, of course, you have flow from the sea into the river. And this basically is the same mechanism that happens in the groundwater, basically the same. You pump water from the underground with the disadvantage that you don't see the groundwater level. And if the level of groundwater, the level of the water table, gets to an elevation that is lower with respect to sea level, you have a flow from the sea of salt water into the aquifer. At the end of the story, at a certain point, your water pumped from the well becomes salted and unusable. Remember that salt water can be, it's basically unusable because you can't use it for irrigation, you can't use it for drinking, absolutely. It causes diseases, and also death if you drink too saline. And also, it's difficult to use it for other uses, like washing cars. It's a problem because then it gets into the sewer system, and the sewer system may have some problems with salt water. You can't use it for washing cars because also corrosion of, you are concerned by corrosion of the car. And you are concerned, you can't use it for flushing the toilet because you are concerned by corrosion and salt deposition into the pipes, so it's basically useful. Okay, so we have this flow, and it is also a concern for the quality of coastal ecosystems because, of course, it affects the life of living organisms like plants, but also fishes and other micro and macroorganisms. Okay. One thing, coastal areas not only collect a great amount of population. Coastal areas today are extremely important from a societal point of view because of tourism, and therefore you understand that it is extremely important to feed coastal areas with water with good quality. And it's an increasing problem, the fact that in coastal areas you have an excess of people during summer and therefore an excess of demand during the nice season. And therefore, overpumping becomes more and more frequent. Increase of tourism, increase of water demands, increase of pumping, increase of salinity of groundwater. And this cannot be remediated. Groundwater cannot be recovered by simply during the winter injecting flow back. Once that an aquifer gets salted, the problem persists. It's not easy to wash it out. For a river it's easier, but even into the river salt has a long-lasting impact, but in a groundwater aquifer the impact is really long-lasting, and remediation, recovery may be extremely difficult. These are the drivers of saltwater intrusion, and first of all, these are I would say macro-scale drivers. So these are drivers acting at the global or continental level, and this is the temporal scale of the impact that they cause. Like the impact may be acute but short-lasting, like a tsunami, and you know, and here on the vertical axis you have the spatial scale. So the tsunami from the regional to the global. The tsunami is placed somewhere in terms of spatial scale between the regional and the global scale, and it's an impulse. So it's an event that occurs in a very short time frame, and also the impact is less lasting with respect to other drivers that we will see. Hurricanes, it's a little bit different, the spatial and temporal scale. And then you have droughts. Why droughts? Because droughts reduce infiltration. Droughts mean reduced rainfall. Reduced rainfall means reduced infiltration in the groundwater body. It means lowering of the water table. And again, if the water table gets lower than the sea level, you have saltwater intrusion. Climate oscillations, climate change, sea level rise, subsidence uplift. And keep in mind that when we talk about sea level rise, usually we talk about millimeters per year. When we talk about subsidence, it may be much more. So they are basically two effects that have the same result. If you increase the sea level, and if you lower the level of the end, in both cases you have a shift of the coastline inland, which means an increase of the risk of saltwater intrusion. We can talk also about shorter spatial scale. We started in the previous graph, we started from the regional spatial scale to the global. Here we start from the local, which is like 1 square kilometer, to the regional 10,000 square kilometers. And here we have different drivers. Land drainage. If you increase, for instance, the extension of the urbanized areas, and you drain these areas with sewer systems, you reduce infiltration. By reducing infiltration, blah, 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 groundwater level decreases, and it can favor saltwater intrusion. And then there is maybe a local climate change, and land use change, same thing like urbanization. And keep in mind, land drainage, it is effective even if you don't urbanize it. If you drain an area, like through a reclamation consortium, like the one that you visited yesterday, if you drain an area, you reduce infiltration, even if it's not urbanized. And groundwater abstractions, river modification, accelerated subsidence maybe for groundwater pumping, for instance. These are the drivers. Understanding the drivers is important for understanding what can be done. And here we have an example of a picture which explains what happens if you look at the upper graph. You have an undisturbed situation. In the undisturbed situation, you have fresh water, which is light blue. Dark blue is salt water here. And with different level of colors, it means basically they indicate the salinity. And in this case, you have the understood situation. When you start overpumping, you see that you have a lowering of the level of fresh water, and lowering the level, you may cause the depletion of areas like lakes or areas that are close to the coastline where there is a storage of freshwater resources, like lakes, the example that she made. And if you lower the level of groundwater resources, then you have intrusion of salt water. Here you see in this graph that the aquifer is divided into two parts, the confined aquifer and the unconfined. We already talked about this difference. And the unconfined aquifer has the water table, the level of the water table, that